Hi, welcome to Lesson 9, Session 1. Today we will take what we know about decimals and we will begin to compare and round the decimals. So up until now, we've been looking at powers of 10, we've been looking at how to read and write decimals, and now we're going to see how we can compare and round decimals. We're going to be working in our Ready Math workbook on pages 167 through 170. So go ahead and open your Ready Math workbook to page 167. Okay, so today we're going to be exploring comparing and rounding decimals. You already know how to compare and round whole numbers. You did that in 4th grade. In this lesson, you will use place value understanding to compare and round decimals. Use what you know to try and solve the problem below. So I'm going to help you get started. So remember, anytime we do a question like this, we're going to do ask ourselves the 3 questions. The first question is, what is this question talking about? The second question is, what is it that we need to find out? And then the third is, what is the important information? So first, let's read the question. Grace chooses one red and one blue button from her button collection. The blue button is 1.2 centimeters or 1 2/10 centimeters wide, and the red button is 1 800 centimeters wide. Which button is wider? So first, what are we talking about? And in this case, we are talking about buttons. This question is really all about buttons. And so what is it that we're trying to find out? We're trying to find out which button is wider. And the important information is that we have a blue button that is 1.2 centimeters wide. And I'm going to circle that 1.2 or 1 2/10 centimeters. And we have a red button that is 1 800 centimeters wide. And I'm going to circle that 1 800. As I have in the past, I'm going to show you 2 different strategies on how I would solve this. But before I do that, I want you to pause it and see how you would solve it to see if you know which button is wider. And if you can just look at it and know which button is wider, then I want you to tell me what is it that tells you which button is wider. Go ahead and do that now. Go ahead and pause, and then when you're ready, come unpause and come back. Okay, I hope that you tried one of your own strategies to find out which button you think is wider, the red or the blue, or excuse me, the blue or the red. So here is the first strategy that I would use. The first strategy is I would turn both of the decimals into fractions, but I need to make them into equivalent fractions because my 1 2/10, if I just said, what does 1 2/10 look like as a fraction, I would recognize that I have, let me zoom out a bit, that I have 1 whole, and then I have 2/10. So that's what that 1 2/10 would look like as a fraction. And then I have 1 800. And I would write that as 1 whole and 800. Now, right now, I cannot compare these 2 mixed numbers. The reason I can't compare them is because I do not have common denominators. In this example here, I have a 10th here and I have a 100th here. I need to make them the same in order to compare and figure out which one is bigger or which one is smaller. So remember the trick that I taught you guys last week. The trick was that if you add a 0 to both the numerator and the denominator, that it makes an equivalent fraction, but it doesn't change the size of the fraction. It just makes it equivalent. So if I wanted to make 2/10 1 and 2/10 an equivalent fraction, my whole stays the same. And so I need to take my 2/10 and I need to make it into hundredths. So if I want to make my denominator 100, I added 1 0 to 10. So that means if I add a 0 to the denominator, I also have to add a 0 to the numerator. Now I have equivalent fractions. So now I can look and see that 1 and 20/100ths is the same, is that greater than, less than, or equal to 1 and 800ths? Again, is 1 and 20/100ths greater than, less than, or equal to 1 and 800ths? To find out, I just need to look at the numerators and see which numerator is bigger. And in this case, 1 and 20/100ths is bigger. So because I know that 1 and 20/100ths is greater than 1 and 800ths, or 1 and 2/10, because ultimately that is what the number is. 1 and 2/10 is greater than 1 and 800ths. So that is one way that I could solve it. But maybe that way doesn't really make sense in your brain. So I want to show you another method that might make sense in your brain, because we don't all think the same way. So another way that we could look at this, and I might say that this is my favorite method, but I don't know. Let's see how it goes, is to use a place value chart. I'm going to go ahead and draw a place value chart on here today. But if you're in class and you have one of these place value charts that your teacher's given you, you can always do the work on here using your whiteboard marker and your eraser, because we have it in this plastic. And you can do the work on here and then just erase it when you're done. So I have my place value chart. I am going to break this apart. I know that I have ones. I know that I am going to have a decimal point. And then I know that I have tenths, and I know that I at least need to go out to hundredths. So I need to go out 2 places. So I'm going to have tenths, and I am going to have hundredths. And then I'm simply going to write each of these decimals into the place value chart. So first I'm going to write 1 and 2/10. So I have 1 and 2/10. Then I'm going to write 1 and 800ths. 1 and I have an 8 in the hundredths, and then I know that I need to put a placeholder 0 in. So there's 2 different ways that you can look at this to decide which decimal is larger. What you can do first is you can start at the ones place, and you're going to see, oh, well, so when you're comparing the decimals, you're always going to start on the left instead of starting on the right like we normally do. So you're going to start over here on the left. They're both a 1, so we know that here they're still equal. So we're going to go ahead and shift over to our next place value. And then we're going to look, which is greater, 2 or 0? Well, the 2 is greater. So because this 2 is greater, that means that 1 and 2/10 must be greater than 1 and 800ths. It doesn't matter that this number here is longer, because it still has a smaller value. Now, if you don't believe me, you can also do a separate method. So if you don't want to do it that way, you also can fill in this box here to make this decimal into hundredths, as well as this decimal. What number can we, or what digit can we add that will not change the value of this number, and we often use it to hold a place. That's right, a 0. So if we want, we could put a 0 in here. That still makes this 1 and 2/10. It's now going to be 1 and 20/100, which, as we know up here, is an equivalent fraction to 1 and 2/10. So it's equivalent. And so now if we don't want it, so if you don't like just going over from place to place, now we can look at what number comes after the decimal. Up here, we have 20/100, and here we have 8/100. So we know without a doubt that 1 and 20/100 is greater than 1 and 8/100, or we know that if we were just looking at the place value, the ones are the same. We move over to the tenths, the 2 is greater, so therefore we know that 1 and 2/10 must be greater. So we would still write it the same. 1 and 2/10 is greater than 1 and 8/100. So let's go back to the question. The question actually is asking which button is wider. So wider in this case is the same as which, it means which is bigger, which is the widest. So in this case, the button that is 1 and 2/10 is wider. So that would be the blue button. So you would answer the blue button is wider. All right. Is that what you came up with as well, or did you use a different strategy? Let's go ahead and go to page 168. All right, on 168, we're going to start out by first looking back. Looking back, we want to figure out which button is wider. Use the greater than symbol. This is the greater than symbol, or the less than symbol, to write an inequality statement that compares the widths of the red and the blue buttons Grace chose from her collection. I just realized that I didn't go over any of the vocabulary with you, so I want to go over what an inequality is, since I have that right here, and then I'll go over the rest later. So, an inequality is a mathematical statement that uses an inequality symbol, so a less than or a greater than, to show the relationship between expressions with different values. So for example, if we had the decimal point 3 and 275 thousandths is greater than 3 and 240 thousandths. And so we're going to really work on that today. But so an inequality is simply comparing two decimals using a greater than, a less than, or an equal to symbol. So in our case, we know that one, oh, let's jump. I don't want to jump the gun too far. We want to write that 1 and 2/10 is greater than 1 and 8/100. This is what's called an inequality. Now let's go ahead and we're going to continue looking ahead. You can use decimal comparisons to help you round decimals to a given place value. Rounding decimals is similar to rounding whole numbers. A number line can be a useful tool for rounding. Place and label the numbers 1 and 3/10 and 1 and 8/10 on the number line below. So let's start and figure out first. It looks like we are going from one whole to two wholes, and we have this 1 and 5/10 in the middle. That tells me that more than likely each of these tick marks is a tenth. But to double check, I'm going to see 1 and 1/10, 1 and 2/10, 1 and 3/10, 1 and 4/10, 1 and 5/10, 1 and 6/10, 1 and 7/10, 1 and 8/10, 1 and 9/10. This would be 1 and 10/10, but we know that 10/10 is the same as 1, so 1 plus 1 is 2. So yes, each of these black tick marks, that's what I call them, tick marks, is worth 1/10. So if that's the case, we need to find out where was 1 and 3/10. Let's count. 1 and 1/10, 1 and 2/10, 1 and 3/10. So here is 1 and 3/10. Now let's continue on to find 1 and 8/10. I don't need to count here because I can start at 1 and 5/10, 1 and 6/10, 1 and 7/10, 1 and 8/10. So here is 1 and 8/10. So we've went ahead and we've marked each of these decimals on our decimal number line. Now, question B says, what is 1 and 3/10 rounded to the nearest whole number? Explain how you know. So we need to take this 1 and 3/10. Now we want to round it to the nearest whole number. That's the key. So if we're rounding it to the nearest whole number, we want to see, is 1 and 3/10 closer to 1 whole, or is it closer to 2 wholes? So just by visually looking at this, 1 and 3/10, I'm going to use some highlighters, is this far from the whole and this far from 2. So is 1 and 3/10 closer to 1 or closer to 2? Just by looking. All right, let's see if you're right. 1 and 3/10 is less than, so remember, halfway is, remember, 5 or more up the score, 4 or less, let it rest. That goes the same for decimals. So if it is not more than halfway, it's going to round down. So 1 and 3/10 is less than halfway between 1 and 2. So we round 1 and 3/10 down to 1. Or we can see that 1 and 3/10 is much closer to 1 whole on this number line. So we're going to round it down to a whole. Now, you guessed it, part C is going to ask us, what is 1 and 8/10 rounded to the nearest whole? So I'm going to use 2 different colors, and I'm going to highlight on the bottom. 1 and 8/10 is this close to 2 wholes. And this close to 1 whole. So just by visually looking at it, 1 and 8/10 is closer to 2 or closer to 1? That's right, it's definitely closer to 2. 1 and 8/10 is more than halfway, so it's past the halfway mark. Here's our halfway. More than halfway between 1 and 2. So we round 1 and 8/10 up to 2. What is 1 and 5/10 rounded up? Or so what is 1 and 5/10 rounded to the nearest whole number? Explain how you know. So remember, when we've got a number that's half, if we were going to separate this it's a little hard because I'm running out of highlighter colors, but it would be that far to 2, and then that far to 1. It is exactly halfway in the middle. And it works the same as a 5 if you're rounding whole numbers. As I mentioned before, 5 or more, up the score. 4 or less, let it rest. So what that means is we round 1 and 5/10 up to 2 because when a number is exactly halfway between two values, you always round up. So when it's halfway, you're going to round it up. And look, I already even had the arrow underneath it, so it's perfect. So we would round 1 and 5/10 and 1 and 8/10 up to 2, and 1 and 3/10 would round down to 1. So right now I want you to reflect. It says rounding decimals and rounding whole. How is rounding decimals like rounding whole numbers? So I want you to answer this question. Rounding decimals and rounding whole numbers are alike because how are they alike? What is one thing that you notice is the same when you round decimals and when you round whole numbers? I want you to go ahead and pause it and answer it, and then when you're ready to move on, unpause it, and we'll go over and fill out our graphic organizer. Okay. So we're going to talk about what we know about compare, but before we get to here, so don't pause it just yet, I want to go over the rest of our vocabulary words because compare is the next vocabulary word. So here are the important vocabulary words for all of lesson 9. I already went over what an inequality was, so you're good to go there. The word compare means to decide, Compare means to decide if numbers, amounts, or sizes are greater than, less than, or equal to each other. So for example, 3 and 37 hundredths is greater than 3 and 96 thousandths. We're just comparing the two. So you'll usually compare by writing it as an inequality. Now the greater than symbol is a symbol that's used to compare two numbers when the first is greater than the second. So greater than, usually some people call it the alligator, and the alligator or Pac-Man, and Pac-Man or the alligator always eats the larger value, or not necessarily the longer value. Up here, look at 3 and 96 thousandths is longer than 3 and 37 hundredths. But 3 and 37 hundredths actually has the greater value. The less than symbol is a symbol used to compare two numbers when the first is less than the second. So in this case, 3 and 9 hundredths is less than 3 and 37 hundredths. So we're going to use the less than symbol, meaning that whatever number comes first is less than whatever number comes second. We use the greater than when the first number is greater than the second. And then finally, just to recap, which we've talked about quite a bit for the last little while, is place value. Place value is the value of a digit based on its position in a number. So remember, we kind of think about our ones as the like the center, and then everything fans out from the center. We also remember that our decimal point always goes to the right of the ones place. So you're always going to have a digit in the ones place, and the decimal, even if there's no part, we still in our brains know that the decimal point always comes to the right of the ones place. We have our ones place, then we have our tens, our hundreds, and our thousands. Or if we're going to our fractional part, we have our tenths, hundredths, and thousandths. Now that you've got your vocabulary down for this coming lesson, now you can look at the word compare. What is it to compare? Comparing is to decide if one number is greater than, and that's the greater than symbol, less than, and this is the less than symbol, or equal to, and that's the equal symbol, another number. So that's what we're doing. We're comparing the numbers to see if they're the same, greater than, or less than. What I know about it is that I can compare digits in each place value to compare numbers. Now, examples of how we can compare numbers, we could use a place value chart, and we could look and go, okay, well, these zeros are the same, so we're going to go over one place value. Remember, we always start on in the largest place value when we're comparing digits. So it's almost opposite what we're used to. We're used to usually starting on the right and moving left. Well, with when we're comparing digits, we're always going to start with the largest value digit. And in this case, well, we've got zeros in the ones, so we're going to move to our tenths. And immediately we see that the 8 is larger than the 5. I like to circle it because that helps me remember which decimal value is greater because I circled this digit. So we know that 8 tenths is greater than 5 tenths. So therefore, 80 hundredths is greater than 52 hundredths because 80 or 8 is, well, I will say 80 is greater than 52 or 8 is greater than 5. We also know that 1 and 3 tenths is, oh, I wrote that backwards. 1 and 3 tenths is definitely less than 1 and 8 tenths. And we know that 1 and 3 tenths is less than 1 and 8 tenths because 1 and 8 tenths is closer to, that should be a 2. Man, I'm just doing great today. We'll make this a 1 and this a 2. There we go. Now it's right. Okay, so we can see that 1 and 3 tenths is closer to 1 and 1 and 8 tenths is closer to 2. Therefore, this value here is greater because it's closer to the greater value. So 1 and 8 tenths is greater than 1 and 3 tenths. And then 1 and 5 tenths is greater than 1 and 3 tenths. 1 and 3 tenths is less than 1 and 5 tenths, and 1 and 3 tenths is equal to 1 and 3 tenths. So go ahead and pause it, get that all written down, and then you're going to go ahead and complete pages 169 and 170 on your own. You will likely have an exit ticket or an Edpuzzle or something else to do today, so go ahead and finish your independent practice and then do your next assigned work. See you soon.